Good morning, everyone. Welcome to the next installment of Test Prep Time. My name is Andrew Peterson. I'm the Director of Education at Method Test Prep. And today we're going to be talking about exponent tricks, exponents in general, but ways to identify challenging exponent questions, the way the SAT and ACT ask questions differently than, say, your regular math teacher would ask about exponents. So how to identify those and how to move through the problems and obviously answer them correctly. So let's just dive right in. Before we do, just very quickly, we're on very frequently with students, working with them on SAT and ACT prep, and with students working at home, especially doing online classes. And actually, for a lot of students, it's not really online classes. A lot of students I meet with just get past work on a daily basis and are basically tasked with teaching themselves the subjects. That's obviously not an easy thing, especially for those districts that have some online learning in place, but really don't have it perfected. One of the requests that I've gotten from a lot of students is more advanced subject tutoring. So while we do work on SAT and ACT, and we'd be more than happy to serve all of you in that capacity, we also work on all subject tutoring. Again, a lot of students I'm working with for test prep have requested bio and chem tutoring, calculus tutoring, because again, they just can't teach themselves the subjects and they find themselves in a position where they feel that they have to. So if you are interested in any tutoring, please feel free to contact us. I'll put a contact slide down at the end of the presentation. But you can reach us at methodtestprep.com/online-tutoring as well, down in this bottom little bubble right over here. Okay, so moving on, let's get to some exponents. This is kind of going to be our primary slide. And for those of you that are mathematically inclined, this can be dense. So for those of you that aren't, this probably looks like a lot of gibberish on here. But our goal today in our quick session is to make a lot of sense out of this, make this more approachable so that we can remember what we're looking at and be able to apply it on the test. What this is saying for exponents in our first line right there is that if you see two terms with similar bases, in this case, x to the a and x to the b, and they're being multiplied by each other, so that dot means in the middle there, that's going to be equal to that same base with those two exponents added together. This is why we have multiplication to addition over here on the left-hand side. Furthermore, if you see two similar bases with exponents being divided one by the other, you're going to subtract the exponents on the other side. Again, if you see a base that has an exponent on it and we're raising that exponent to another exponent, we will be multiplying these exponents. And if we see, same base, our x over here, with an exponent that is under a radical, this is radical b right here, then in that case, we will divide the exponents. So again, the big challenge here is being able to actually realize what we're doing, dealing with the questions themselves, but also remembering all this information. Because there are a bunch of different operations here, multiplication, division, addition, subtraction, we have rooting, we have exponents raised to exponents, it's really easy to get this stuff mixed up. So let's talk about a little trick and a nice easy way to remember this on the test. And the best way to figure this out is to get started and have a quick conversation about mathematical operations in general. Let's all flash back to early grade school. The first thing that we learn how to do is we learn how to add. We learn addition. Maybe that's first grade. And that's our base level increase. Notice this is over in the increase column. And then after that, maybe one grade level later, you learn to subtract, and this is your first level of decrease. From there, you learn to multiply. You learn multiplication. And this is kind of a greater magnitude of addition. Numbers get bigger much faster. And in the same vein, after subtraction, you learn division, and numbers get smaller much faster. And then after that, from multiplication, we find exponents, which is again an even higher order of multiplication, higher order of increase. And we see the same thing when we go from division to roots. So we've sort of learned this hierarchy in our education, where we go from addition to multiplication to exponents higher and higher, subtraction to division to roots. This is important to remember because if we ever do forget that master slide that I had showing the relationships between exponents and what to do when you see certain relationships with bases, you can sort of back solve and figure this out because there's one constant that you can keep in mind that's going to help you remember what to do and when to do it. And that's that you want to take a step back. Notice in quotation marks, this is just kind of keeping it a little colloquial here. Take a step back from the base operation that you see. So if we see exponents, right? Take a look over here on the left. We see exponents being raised to other exponents. A is being raised to B, exponent to exponent. If we see that, what do? Well, we multiply. We take those two exponents, A and B, and we multiply them over on the other side. If we see multiplication, we see base operation. The operation between the bases is multiplication. Okay, that's fine. Well, we're going to take a step back mathematically and operationally, and we're going to add those exponents, A plus B. Continuing on, if we see roots, right, over here on the left, we see x to the a is under the bth root, then that means that we're going to divide. What do? Division. And we can see that a is being divided by b right over here. And lastly, of course, following on the same vein, if you see division, two terms with similar bases being divided by each other, well, what do? Yeah, we subtract those exponents, and that's how we get our a minus b right over here. So what to look for? Looks like Adobe Connect went a little wild with the bullet points here. What to look for? You want to look for weird exponents, right? Now that we know what to do, we need to kind of figure out when we're dealing with these challenging exponent questions. You want to look for weird exponents. And what I mean by that is not a 2 or 3, right? If we see something like x squared minus x minus 6 equals 0, well, this isn't the easiest problem you could possibly get on an SAT, just fixing that x there. This isn't going to make us extremely uncomfortable. It's probably going to be a relatively base level factoring question. So again, this 2 right here shouldn't throw us for a complete loop on a question like that. But what you are looking for instead of this are variables in your exponents, like x and y. Like if you see something like 2 to the x, this is going to raise a red flag because you're going to say, well, that doesn't really make me very comfortable. So when we see something like this, we should be thinking we're going to use those exponent rules that we just discussed. Maybe fractions, look for these as well. If we see something like 3 to the 1/2, this is important because, again, this probably shouldn't make us feel too comfortable. And bases and coefficients that are perfect squares or cubes, that's another nice sign. If you see numbers like 4, 8, or 9, as I have over there to the left, if those are raised to certain exponents, this is another indicator that you're going to be using the exponent rules that we just talked about. All right, so let's actually see some problems. So this first one right here is asking us what's equivalent to r to the 2/5 multiplied by the square root of r. Okay, let's think back to what we were talking about a little bit earlier in the lesson. If we see multiplication right here, this means that we're going to take a step back and we're going to add our exponents. So once we figure out what our exponents are in this case, we are going to add them together to get some exponent up here for our r term. Obviously, taking a look at your answer choices, once we find this sum, and we'll talk about doing that in a second, we're either going to get a sum of 1/5, we'll get a sum of 3/10, 3/7, or 9/10 in this case. And this is just a nice reminder in general. This doesn't even have anything to do with exponents. Make sure you're looking at your answer choices on your test. It's very important to do this to make sure that you're aware of what the SAT or ACT want you to do in a case where you get an exponent question. Don't do any extra work you don't have to. Be aware of what you have in front of you and make sure you're working toward a solution that's going to be in line with those answer choices. So again, we need to figure out how to add these exponents, but obviously there's a bit of a hiccup here, right? This term right here, this radical r, it doesn't really seem to have an exponent. Well, what we know is radical r, when we don't actually see a number right here, this is indicative of the fact that we're dealing with a square root. So that's really a 2, we just don't write it there. In the same vein, there's actually an exponent of 1 above the r right here. Again, we never write that, but that's true. So really, the square root of r is the square root, we have a 2 right here, of r to the first power. Now remember what we talked about when we talked about roots, right? Roots, when we take a root in this case, what do? We take a step back and we divide the exponents. So the square root of r is really r to the 1 over 2. Notice that I'm dividing the exponents, right? We see roots, that's that third level of magnitude. We take a step back and we divide. So now that we know that the square root of r is equal to r to the 1/2, we can actually move through the problem and we're in business here. So we're going to take r to the 2/5. We are going to multiply that by r to the 1/2. And again, what we're doing here, since we're multiplying, is we are going to add those exponents. So this is going to be equal to r to the 2/5 plus 1/2, right? Multiplication, so we do addition. Okay, so really what we need to do now is just add these two fractions. We need to add 2/5 and 1/2. Okay, and if we remember back from our adding fraction days, we need a common denominator. We can't just add directly across. The least common multiple of 5 and 2 would be 10. So what I can do over here is multiply this fraction by 2 over 2. That's going to make it equal to 4 over 10. I'll multiply this fraction over here, and I'm going to try to sneak this in, by 5 over 5. And that's going to give me 5 over 10. And now I can just add straight across. I'm going to carry that common denominator of 10 over to the right-hand side and put that 9 up on top. This is telling me that our new exponent should be 9 over 10, and we can therefore safely select answer choice D in this example. All right, let's check out another one. Ooh, all right, this one looks challenging. So we've got some roots, we've got some division, we've got a lot of stuff going on here. Let's take the first step and just simplify these radicals into exponents. Let's do this first. I'm going to go ahead and just put this 2 in here for us just to make it easier. Remember, they don't do that on the test, but we're going to do it here just to help ourselves make sense of what's going on. All right, so this radical here, x to the 5th, the square root of x to the 5th, well, that's really going to be x to the 5 over 2. Remember our rule. We see roots, and so we divide 5 over 2. All right? And we're going to be dividing this by x to the 4 over 3. And this is going to be equal to x to the a over b. Okay, great. So now that I took care of these roots, well, we need to go through and we need to figure out what we're doing when we divide. Okay, well, if we're dividing terms with similar bases, we take a step back and we subtract. So we're really doing 5 over 2 minus 4 over 3. And this is going to be equal, in this case, to a over b. And we can see already from a challenging question from the beginning, we've simplified it, and now we're working directly toward our solution, which is the value of a over b. All right, well, we're working with fractions again, and we are subtracting. Remember, for adding and subtracting, we do need a common denominator. Least common multiple, and the common denominator of 2 and 3 would be 6. So I'm going to multiply this by 3 over 3. I'll multiply this one, sneak it in there again, by 2 over 2. And we're going to see 15 over 6 minus 8 over 6. And we are going to get 7 over 6. And in this case, this will be equal to the value of a over b. Now, this was a grid-in question, so there weren't any multiple choice answers to go by, but we do know that we need a numerical answer, and 7 over 6 is that answer. All right, we've got 2 more questions to go. We're doing great. Let's check this one out. Probably out of all the ones that we're going over, when I'm working with students, this is one that they kind of drive themselves crazy on. And that's because this exists in a no calculator section. So before we actually get into the solution, let's talk about the challenge here. A lot of students see x to the 8th equals 2, and they say, hey, great, well, if I have a calculator, I can just take the 8th root of 2. I'm going to get something really small and really ugly, but that's fine, because once I find what that is, right, x equal to whatever that small number would be, I would then just raise this to the 24th power. And when I do that, I'm in great shape because I'll be able to solve for x to the 24th. Now, like I said, they don't have a calculator to do this, which is really the most frustrating part. And it's doubly frustrating because in math classes, literally for students' entire lives, they're trained to solve down for x. If we get x to the 8th grade, solve for x, and then build it back up to x to the 24th. So the SAT and ACT, they take advantage of this and they write these questions to confuse students. But remember what we were just learning, and remember how we need to approach this, just as I'm going back here and deleting a couple of these things that we were just working on. We need to realize that we were given a very weird exponent here. Actually, a couple of them. We were given an 8 and a 24. We don't see this every day. So we should be thinking to ourselves, hey, we probably need to use those exponent rules we were just talking about. And another nice tip, especially when we get stuck on the SAT or ACT math, another nice tip is to make sure that you know where you are and what you have, and also what you're trying to solve for. It seems like a pretty obvious tip I'm giving right there, but on the test, when you're working hard, you're working toward your time frames, it's very easy to lose sight of that. You get tunnel vision on a problem, and you revert back to the way you do math in math class. Remember, we want to have special and tailored strategies to the SAT and ACT to ensure our success. So look at where you are. We're at x to the 8th. Look at where we're trying to go. We're trying to go to x to the 24th. And there is a relationship between these numbers, right? 8 times 3 is equal to 24. Okay, interesting and very relevant here, because if we remember, for multiplying, right, 8 times 3 equals 24. Well, if we're multiplying, that means that we actually need to raise our exponent to another exponent, right? When we raise an exponent to an exponent, we multiply. 8 times 3 is 24. Okay, well, if we're raising x to the 8th to the 3rd power, I can do this up in the problem just so we can visualize it a little better. Well, then we just raise the right-hand side over here to the 3rd power. And yeah, it's true that we don't have a calculator, but 2 to the 3rd is just the same as 2 times 2 times 2 for those of us that don't know. And we can do 2 times 2 and get 4, and we can multiply again by 2 to get 8. If you just knew that 2 to the 3rd was 8, great job, you could finish it a few seconds faster, and we would be able to select answer choice D in this case, without even knowing what the value of x is. All right, let's try one more, and then we're going to call it a day. So this one is an issue with students as well. You seem to get this piece of information up front, 3x minus y equals 12, and it seems to have nothing to do with anything. But if you've got a nice set of eyes, and after watching this video, you're definitely going to have a nice set of eyes, you notice this subtraction that's occurring between x and y right here. And it is not a coincidence at all that we see division between our base terms. Remember, when we divide terms with similar bases, we subtract the exponents. Now, I just said when we divide terms with similar bases, we subtract the exponents. And some of you are probably saying to me right now, well, Andrew, we don't have similar bases, right? We have an 8 to the x, and we have a 2 to the y. All right, yeah, this is a problem because we can't just immediately subtract. But there is a way that we can actually make the bases similar. And remember, this problem has a bunch of things that we're looking for. It has variable exponents, x and y. It has 8, which we said at the end of that previous slide to look out for. This is a perfect cube, and we actually just dealt with it in the previous problem, which is why I put that problem before this one. We know that 8 is exactly the same thing as 2 cubed. So what I'm going to do here, it's not changing the value of anything. I'm just going to replace this 8 with a 2 to the 3rd, still raised to the power of x. Sorry, a little bit sloppy. Divided by 2 to the y. Okay, well, first things first, let's do what we need to do over here. 2 to the 3rd to the x. Well, we're raising an exponent to another exponent, so what do? Yeah, we take a step back and we multiply. This is now 2 to the 3x over 2 to the y. Okay? And we're going to carry that same base over. We're going to have that 2 over there. And notice that since we're dividing, we will be subtracting our exponents. So 2 to the 3x over 2 to the y is really going to be equal to 2 to the 3x minus y. And now this piece of information that we were using before that we really thought had almost nothing to do with anything allows us to make a direct substitution. Because if I know that 3x minus y is equal to 12, well then great. This 3x minus y down here is also equal to 12. And therefore I can substitute the 12 in and realize that my answer over here is answer choice A, 2 to the 12th. All right. So a couple reminders for everyone. Online self-paced program, it's a great tool. It really is. I know I'm biased. I love it because I love SAT and ACT prep, but it's a great tool, not only to offer test prep, but also for regular educational progress during school closures. I know that things are sort of continuing to be pushed back. It's important to keep our brains busy. I love doing these test prep times because it keeps my brain busy. And we're given a great deal and a great offer, 50% off the online program using the code FUTURE. So keep that in mind. SAT and ACT classes for all situations. Yeah, I know we're kind of hanging in limbo right now, but I guarantee that the SAT and ACT, they will be back again. We will be taking these tests again. And rather than being behind the curve after this time off, we should be ahead of the curve, be competitive. And a great way to do that would be to take a class with us. So visit methodtestprep.com/classes. We have multiple times and days for those classes. And lastly, feel free to give us a ring, 1-877-871-PREP if you have questions about anything. We work with families and we're on the phone with families every single day, helping them figure out the best prep plan for them. No obligation for anything. If you just want to talk and get things set and move on it later, we'd love to speak with you. So feel free to do that. Feel free to subscribe to our blog, info.methodtestprep.com/blog. And we will see you again on Test Prep Time tomorrow. Thanks again for joining us, everyone.